Hello students, in the previous session we have studied about refraction of light, and in this session we are going to study about lenses, and we have already studied spherical mirrors in 9th standard, and therefore here are a few questions related to spherical mirrors, and we will begin our session with the can you recall type of questions. And therefore here is the first question. Indicate the following terms related to spherical mirrors in figure 7.1, that is the pole, center of curvature, radius of curvature and the principal focus.
So here there are diagrams which show the different terms which are related to spherical mirrors. The first mirror is a concave mirror and the second is a convex mirror, as you can visualize here in the diagram. And the different terms which are related to these mirrors are pole, radius of curvature, center of curvature and principal axis. And the principal focus is a point which lies on the principal axis.
Now the next question here is, how are concave and convex mirrors constructed?
So here the concave and the convex mirrors, they are also known as spherical mirrors, and these spherical mirrors are constructed by using a hollow spherical glass, and this one surface of the hollow spherical glass, it is made a reflecting surface. And as you can visualize here, that in a concave mirror, the inner surface, it is the reflecting surface, whereas in a convex mirror, the outer surface or the convex surface is the reflecting surface. And for reflection to take place, one side of the glass, it is coated with a shiny substance or a shiny material. Now let us see what is a lens. So a lens is a transparent medium bound by two surfaces, and basically the lenses, they are of two types. First, a convex lens. The lens which has two spherical surfaces which are puffed up outwards is called a convex or a double convex lens, and this lens, it is thicker near the center as compared to the edges. And secondly, the lens with both surfaces spherical on the inside is called a concave or a double concave lens, and this lens, it is thinner at the center as compared to its edges. Figure 7.2 shows different types of lenses: biconvex lens, biconcave lens, plano-convex lens, plano-concave lens, positive meniscus and negative meniscus. And figure 7.3 shows cross sections of convex and concave lenses, where you can very easily see the center of curvature, that is C1 and C2, radii of curvature R1 and R2, and also the optical center.
Now let us study the different terms related to the lenses. So the terms related to the lenses are center of curvature C, radius of curvature R, principal axis, optical center O, principal focus F, and focal length small f.
So the center of curvature C is the centers of spheres whose parts form surfaces of the lenses are called centers of curvatures of the lenses. And here, a lens with both surfaces spherical has two centers of curvature as C1 and C2. Second is the radius of curvature R, and the radii R1 and R2 of the spheres whose parts form spheres of the lenses are called as radii of curvature of the lens. Then is the principal axis, the imaginary line passing through both the centers of curvature is called as the principal axis of the lens. And then optical center. It is denoted by O, and the point inside a lens on the principal axis through which the light rays pass without refraction or without changing their path is called as the optical center of a lens. Then next is the principal focus, and principal focus may be defined in terms of a concave lens and a convex lens. So when light rays parallel to the principal axis are incident on a convex lens, they converge at a point on the principal focus, and this point is called as the principal focus of the lens. Here you can visualize this principal focus. Principal focus related to the concave lens may be defined as rays of light traveling parallel to the principal axis of a concave lens diverge after refraction in such a way that they appear to be coming out of a point on the principal axis, and this point on the principal axis is called as the principal focus of the concave lens. Therefore, we can say that a concave lens is a diverging lens, whereas a convex lens is a converging lens. And then the focal length, it is the distance between the optical center and the principal focus of a lens, and it is called as the focal length.
आणि ही जी टर्मिनॉलॉजी आहे ही टर्मिनॉलॉजी आपल्याला समजणं, we should understand the terms which are related to the concave lens and the convex lens, and then only we can be able to draw the diagrams which are the diagrams for refraction, and these are referred to as the ray diagrams. आणि मग रे डायग्राम्स आपण कशा पद्धतीने काढायचे आहेत, त्यासाठी कोणत्या गोष्टी लक्षात ठेवायच्या आहेत ते आपण अभ्यासूयात.
आता एक लक्षात घेऊयात आपण की ज्यावेळी आपल्याला रे डायग्राम्स काढायचे आहेत, इमेजेस फॉर्मेशन हे आपल्याला स्टडी करायचं आहे, त्यावेळी काही रूल्स आहेत रिफ्रॅक्शनसाठी. देर आर रूल्स फॉर रिफ्रॅक्शन अँड दीज आर 3 रूल्स ऑफ रिफ्रॅक्शन. आणि मग हे कलेक्टिव्हली आपण इथे प्रेझेंट केलेले आहेत इन बोथ द कॉन्व्हेक्स अँड द कॉन्केव्ह लेन्सेस. मग जे ए आणि बी डायग्राम आहे ती थोडीशी लक्षात घेऊयात आपण की the ray of light, the incident ray of light, it is passing through the optical center and it remains undeviated, that is it does not change its direction. हे झालं A आणि B चं. And then in C and D figure you can observe that the ray of light, it is parallel to the principal axis and then it passes through the focus in case of convex lens as well as the concave lens. This is observed in C and D. मग एक लक्षात घेऊयात आपण की कॉन्व्हेक्स लेन्स मध्ये जो लाईट रे आहे इट इज पासिंग थ्रू द फोकस ऑन द अदर साइड, बट इन केस ऑफ कॉन्केव्ह लेन्स इट इज पासिंग थ्रू द फोकस ऑन द सेम साइड. म्हणजे अशा पद्धतीने ही सेकंड म्हणजे सी आणि डी डायग्राम्स आहेत. आणि लास्टली ज्या ई आणि एफ या ज्या रे डायग्राम्स आहेत यामध्ये रे ऑफ लाईट विच इज इन्सिडेंट थ्रू द फोकस, it remains parallel to the principal axis after refraction, and this is observed in both the convex as well as the concave lenses. आणि परत एकदा हे जे रूल्स आहेत हे खूप महत्त्वाचे आहेत, म्हणून आपण हे परत एकदा थोडेसे समजून घेण्याचा प्रयत्न करूयात. ओके, तर फर्स्ट रूल इज a ray of light, that is the incident ray of light which is parallel to the principal axis, it will pass through the focus. And here in case of convex lens it passes through the focus on the right side, whereas in case of concave lens it passes through the focus on the left side. आणि सेकंड जो रूल आहे, ray of light which is incident through the focus will become parallel to the principal axis after refraction. आणि मग इथे ज्या डायग्राम्स आहेत दे आर रिलेटेड टू द कॉन्व्हेक्स लेन्स ॲज वेल ॲज कॉन्केव्ह लेन्स. म्हणजे दोन्ही आपण इथे रिप्रेझेंट केलेले आहेत, आपण इथे दाखवलेले आहेत की जेणेकरून तुम्हाला हे समजावं यासाठी आपण दोन्ही डायग्राम्स इथे वी हॅव शोन दीज डायग्राम्स. आणि लास्टली जो थर्ड रूल आहे इट इज अ रूल that is ray of light which is passing through the optical center it goes without any deviation to the other side of the lens. म्हणजे या ठिकाणी त्याचं डेव्हिएशन होत नाही, डायरेक्शन चेंज होत नाही, हे इथे महत्त्वाचं आहे. आणि मग हे जे रूल्स आहेत, हे रूल्स आपण आत्मसात करूयात, हे रूल्स आपण स्टडी करूयात, व्यवस्थितपणे ते समजून घेऊयात. कारण कुठल्याही रे डायग्रॅम्सचा बेस जो आहे, जो फाउंडेशन आहे, दीज आर द रूल्स and these are known as the rules for refraction. म्हणजे अशा पद्धतीने हे रूल्स आपण व्यवस्थितपणे समजून घेण्याचा प्रयत्न करू आणि त्याचप्रमाणे हे काढण्याची प्रॅक्टिस सुद्धा करूयात. ओके.
आणि या रूल्स नंतर आपण हे स्टडी करूयात की द नेचर ऑफ इमेज which is formed by a convex lens and the nature of image which is formed by a concave lens.
Now let us study here the images formed by the convex lenses. And the rules for refraction are: first, when the incident ray is parallel to the principal axis, the refracted ray passes through the principal focus. Second, when the incident ray passes through the principal focus, the refracted ray is parallel to the principal axis. And third, when the incident ray passes through the optical center of the lens, it passes without changing its direction. And these three rules of refraction, they are very important for understanding the ray diagrams related to the image formation by a convex lens. Here is a table on page number 83 which represents the position of the object, position of the image, size of the image, and nature of the image. And these are the images formed by the convex lenses and for different positions.
आणि या ठिकाणी आपण सेकंड जो पॉइंट आहे when the object is placed beyond to f1 आणि सिक्स्थ पॉइंट जो आहे when the object is placed between f1 and o याचा आपण स्टडी करणार आहोत. तर एक लक्षात घेऊयात आपण की बियॉन्ड टू f1 असेल तर द इमेज इट इज रियल इमेज and for sixth one when the object is between f1 and o the image it is a virtual image. म्हणजे आपण एक रियल इमेज फॉर्मेशन आणि एक व्हर्च्युअल इमेज फॉर्मेशन हे आपण इथे स्टडी करणार आहोत.
So here this is figure 7.7 from our textbook, and real image it is formed by a convex lens when the object it is placed beyond 2f1. म्हणजे 2f1 च्याही पुढे ज्यावेळी आपण ऑब्जेक्ट प्लेस करत आहोत त्यावेळी आपल्याला रियल इमेज मिळणार आहे. अँड हिअर द रेज विच आर शोन आर द रे ऑफ लाईट विच इज पॅरलल टू द प्रिन्सिपल ॲक्सिस. आफ्टर रिफ्रॅक्शन it passes through the focus f2 on the other side of the convex lens. And secondly, the ray of light which is passing through the optical center, it remains undeviated or it does not change its direction. And then the point B dash is the point where the refracted rays they actually meet each other, and whenever the rays of light they actually meet each other, a real image is formed. And here this real image it is indicated by A dash B dash, and it is a inverted image. It is a smaller image than the object.
आणि अशा पद्धतीने ही जी इमेज आपल्याला मिळाली ही इमेज म्हणजे रियल इमेज where the refracted light rays they actually meet each other. आणि यानंतर जी डायग्राम 7.8 आहे, this diagram it shows the image formation by a convex lens, and here a virtual image it is formed.
So here this is a diagram which shows the virtual image formation by a convex lens. And here the object AB it is placed within the focal length of the convex lens, that is it is placed between the optical center and the principal focus f1. And then the ray of light which is parallel to the principal axis, after refraction it passes through F2, that is the focus on the other side of the convex lens. Secondly, the ray of light which passes through the optical center, it does not change its direction and it remains undeviated, or it passes undeviated through the lens. And when these two rays, that is the refracted ray and the ray of light passing through the optical center, they are extended on the same side of the object, it is observed that these two rays, that is the refracted ray and the ray of light passing through the optical center, they appear to come from the point B dash on the same side of the object. And here a virtual image, a erect image and an enlarged image of the object AB, it is formed. And this image, it is called as virtual image because the light rays, they do not actually meet each other, but they appear to come from a point B dash which is on the same side of the object.
म्हणजे अशा पद्धतीने एक गोष्ट आपण लक्षात ठेवूयात की कॉन्व्हेक्स लेन्स इट फॉर्म्स टू डिफरंट टाइप्स ऑफ इमेजेस, दॅट इज द रियल इमेज ऑल्सो अँड व्हर्च्युअल इमेज ऑल्सो. म्हणजे हा पॉइंट हा खूप महत्वाचा आहे, हे आपण लक्षात घेऊयात. Lastly, a very important conclusion here is that when the object is placed within the focal length, we get a virtual image, and when the object is placed between any position from infinity to F1, we get a real image. And with this, let us study the image formation by concave lenses. So let us first study the rules for refraction for the concave lenses in order to understand the image formation by concave lenses.
So the first rule is, when the incident ray is parallel to the principal axis, the refracted ray, when extended backwards, it passes through the focus. Secondly, when the incident ray passes through the focus, the refracted ray is parallel to the principal axis. And the third rule is, when the incident ray passes through the optical center, the refracted ray remains undeviated, that is, it does not change its direction. These three rules of refraction are important to study the ray diagrams or the image formation by concave lenses. So this is a ray diagram which shows image formed by a concave lens, and here the object, it is denoted as PQ, which is placed between F1 and 2F1 in front of a concave lens. Ray PA, it is an incident ray parallel to the principal axis. AD is the refracted ray, and when it is extended backwards, it passes through F1. And another ray, that is ray PO, which passes through the optical center, it goes in a straight line, that is, it remains undeviated. And here P dash Q dash is the image of the object formed, and this image P dash Q dash is a virtual image. It is on the same side of the object, it is smaller in size, and it is between the optical center and the focus F1. And here is a table which shows the position of the object, the position of the image, the size of the image, and the nature of the image when an object is placed in front of a concave lens.
आणि या टेबलचा आपण जर व्यवस्थितपणे अभ्यास केला तर आपल्या असे लक्षात येईल की whenever a concave lens is used, the image which is formed, it is a virtual image. म्हणजे virtual image या ठिकाणी तयार होणार आहे, but a convex lens gives both the types of images, that is a real image as well as a virtual image. But remember that concave lens gives only one type of image, that is a virtual image. Lastly, आपण एक लक्षात घेऊयात की refraction, this is a chapter in which ray diagrams and a good practice of the ray diagrams, it is very important in order to understand the concepts. And so, let us practice the ray diagrams and have a good day.